The Spanish company, InEngine, has developed a unique internal combustion engine which they term as single-stroke. This engine integrates the best features from traditional internal combustion engines, those used in heavy military equipment, aviation, and some thermal locomotives. However, the drawbacks of these conventional engines have been eliminated. As a result, this engine, with its compact size and simple design, delivers exceptional power. The engine block is crafted from aviation-grade aluminum and sports a circular shape housing 4 symmetrically arranged cylinders. On either side of the engine, there are plates featuring curves of a specific shape, serving as the crankshaft of the engine. The connecting rod, with pistons mounted on it, moves along these guides. This assembly is then inserted into the engine block. The reverse side of the engine follows the same setup, with the plates connecting with each other. So, in this engine, there are 4 cylinders and 8 pistons. These are all the main components of the engine, which makes it quite simple, compact, and lightweight. But let's see how it operates from the inside. Although the Spaniards call it a single-stroke engine, it operates on a 2-stroke cycle where the entire cycle is completed in 2 piston movements. Each cylinder houses 1 spark plug and 1 injector. Pay attention here to the shape of the grooves in the piston, which is determined by the positioning of the spark plug and the injector. Now, we can see where the intake and exhaust occur. They are located at the farthest points of the piston movement to allow for cylinder scavenging. That is, when the piston reaches the farthest dead center, the exhaust opens first and the exhaust gases start to exit. Then, the intake opens to carry out scavenging and the exhaust gases leave. The exhaust then closes, while the intake remains open and the cylinder fills with air. Now, the intake closes, initiating compression, ignition, and the process repeats. The asynchronous opening and closing of intake and exhaust ports occurs due to the asynchronous movement of the plates themselves. Thus the intake and exhaust ports alternately open and close. In heavy-duty and military machinery, a design utilizing 2 pistons per cylinder is often employed. One noted drawback is that during scavenging, these engines may behave unstably at low speeds. However, this problem appears to be remedied by the use of supercharging. The Rex engines from InEngine have an advantage in this respect. Here, instead of a crankshaft, there are plates where the pistons move along guides. Due to the shape of these bends, the pistons are detained at the top and bottom dead centers for a longer period, thus allowing more time for the exhaust gases to exit at the top dead center. Meanwhile, at the bottom dead center when the pistons, so to speak, come together, this allows for a more efficient combustion of the fuel-air mixture. Another technology is also employed to increase efficiency in this engine. Through the use of a special rod between the plates, the compression ratio can be adjusted in real time. This is accomplished by slightly rotating one plate relative to the other. Consequently, this internal combustion engine can easily adapt to different types of fuel and varying octane numbers, or aim for maximum efficiency. At low loads, the compression ratio can be at its maximum, thus achieving maximum efficiency and power at low speeds. Conversely, at high loads, to prevent undesirable detonation and to enable the engine to deliver maximum power, the compression ratio is reduced. This also regulates the size of the opening and closing of the intake port. Another advantage of this engine is the complete absence of vibrations, as the pistons are directed towards each other. Thereby any oscillations are compensated. As for the lubrication system, it is implemented through channels, as in a 4-stroke engine. And now, let's answer the question: why do the Spanish refer to this engine as a single stroke? The reason lies in the fact that this engine performs 4 times more work than a 4-stroke engine and twice as much as a 2-stroke engine in a single full rotation of the plate. That is, in a crankshaft rotation. In essence, this engine operates on a 2-stroke cycle, and the single-stroke label is more of a marketing ploy to attract your attention. Now let's compare this engine in more detail with the 4-stroke and 2-stroke engines, as well as with a similar engine used in heavy machinery. The advantage of a conventional 2-stroke engine over a 4-stroke engine is that it is smaller, lighter, simpler, and can deliver up to twice the power at the same RPM and in the same time span. However, its drawback lies in the lubrication system, where oil must be added to the fuel, which is not good for the environment. Additionally, part of the fuel does not burn, which is also bad for fuel consumption, and hence the engine efficiency is lower. The IN engine eliminates these problems. Here, the lubrication is like that of a 4-stroke engine. There's a delay at dead centers that allows for more efficient combustion of the fuel-air mixture. And the intake and exhaust are at the dead points when the pistons are at their furthest distance from each other. Plus there's a delay at the dead points for effective scavenging. The issues with the 4-stroke engine are that it is large and heavy, delivers less power in the same time frame, and its design is much more complex and expensive. However, compared to the conventional 2-stroke engine, it has higher efficiency, better reliability, and better environmental performance. This is why we all use 4-stroke engines in our cars. The Rex engines have managed to significantly reduce the size and weight, and the design has become simpler. Here, there are no belts or chains to rotate the camshaft, no valves, plus there's real-time compression ratio adjustment, and the piston movement is non-linear with a delay at the dead centers. Therefore, the efficiency here is 22% higher than in the 4-stroke engine, and the weight is 70% lower. They claim that this engine will meet the Euro 7 environmental standards and can also adapt to different types of fuel. Currently, there are 2 versions of these engines. The first E-Rex is 0.5 liters, with a power output of 120 horsepower and weighing just 35 kilograms. Its tests were demonstrated in a Mazda MX-5. So far, only 3 such prototypes have been developed. And now we move on to the Rex B engine, which is already available for purchase as the production capacity is currently being expanded for its mass production. The Rex B engine is primarily designed for aircraft. Weighing only 4.59 kilograms and with a displacement of 125 cubic centimeters, this engine offers a power output of 22.7 horsepower on gasoline. Moreover, its dimensions are just 21.5 centimeters by 14.5 centimeters, comparable to the size of a human palm. Theoretically, if this engine was installed as a generator in a Tesla Model 3 electric car right now, the electric vehicle could travel at a speed of 100 kilometers per hour without any battery drain. This engine can already be purchased for €3,470. The next version will have a displacement of 250 cubic centimeters and is likely to have a power output of 50 horsepower. Production of the E-Rex engine with a 0.5-liter displacement is likely to start only in 2024. Plus, there's a version under development with a 0.7-liter displacement and a power output of around 170 horsepower. Please share your thoughts on the engines from IN engine in the comments. Don't forget to hit the like button and share this on social media.
I wonder if God got a plan for everyone.